Good morning all. Here is a new bus power supply and it is model MDLL2015N00 revision D2. We're going to test this power supply on the bench and I'll show you something that's very peculiar that will aid you in troubleshooting these bus power supplies, aid you in testing it on your bench. But first, let's get it powered up. We're going to apply from this variac 220 volts AC single phase to pins 1 and 3 of this green Phoenix connector. Then we're going to apply 380 volts AC 3-phase to L1, L2, and L3. And what should happen, and here's the peculiar part, but what should happen is there's a DC contactor and it routes the output of the 3-phase bridge to these terminals up underneath this lid right here. You'll see them in a little bit. But that won't happen until we perform one more connection, and we'll get to that. So let's connect. Everything's turned off right now. Let's connect our variac to pins 1 and 3 of the green connector. If this was sitting on the wall, this would be the top. And on the Phoenix connector, the top row 1, 2, 3, the very top pin is pin 1 in relation to the top of this bus power supply. So we're still turned off right there. Let's connect our 3-phase to L1, L2, and L3. It's turned off. We're okay. We're not going to get lit up today. Okay. Here's L3. There's L2. There's L1. Okay. Let's connect ourselves to the power plant. Okay, we just turned on the variac and the green control power LED is on. Let's go over here and apply the 380 volts AC 3-phase to L1, L2, and L3. Did you hear the contactor energize? Did it click? I didn't hear it. Well, let's go remedy that problem. Okay, I've turned the 380 volts AC 3-phase off. Let's get unplugged from the wall just to be safe. There, we're unhooked. We have 2 power sources here. Don't forget to turn the other one off. So, return 220 volts AC single phase off. Now here is what will make that contactor energized. We have to connect a resistor to this 2-terminal gray connector up here. That is the regenerative braking resistor connector. So we have to connect this resistor. This is a 25 ohm, 225 watt resistor. Let's get that connected. Get this back a little bit. I got these pavers and these blocks of wood bookending this bus power supply so it don't fall over. There's our regenerative braking resistor connected. Let's get closer. Alright, we've just applied 220 volts AC single phase to pins 1 and 3 right here. We have the green control power LED is on. Let's apply the 380 volts AC 3 phase to L1, L2, and L3. Did you hear it energize? Let's see what we got. Alright, the green power LED is also on. Let's open up the door and we will measure our DC bus voltage at these two terminals right here. You have to have this connection to the regenerative braking resistor for that DC contactor to energize and route the voltage from the three-phase bridge out to these terminals out here. Now with the regenerative braking resistor of 25 ohms, 225 watts connected to this gray connector, this is our regenerative braking resistor connection, we'll power everyone up and we'll measure our DC bus voltage out here. Alright, did you hear that contactor energize? We should have a DC bus. There we do. 536.3 volts DC on these terminals right here. And our green power LED is on, as well as our control voltage LED. Both LEDs are on. Good, good. Let's measure that again. 534.8 volts DC. There you go. So, if you're ever wondering why your contactor doesn't energize when you have this powered up on your bench, take a look to see if you have a regenerative braking resistor connected to this gray connector right here. That's the secret. In the machine you wouldn't have to worry about it because it would be connected, but out here on the bench you have to connect a resistor there. Otherwise you won't have no DC bus voltage out there on these terminals right here. So at the end of the video I'll put up the connections and you'll be able to test your new bus power supply. Let's take a look at what's inside. Now right down here is your three-phase bridge rectifier. Here's your L1, L2, and L3 line coming in. Here's your bus ground is the blue wire, bus plus is the red wire, and this part number is Sanrex, manufactured by Sanrex, part number DF30CA160. Over here is the contactor that routes the DC from the three-phase bridge rectifier out to these terminals and bus capacitors. Now up here is bus plus and here is bus ground. Over here is the control power supply, and over here is the power board. Underneath here you can't see it, but there's two, I can't tell what they are because they have a tab holding them to the heat sink. I don't know if they're MOSFETs or NPN transistors, but there's two of them in parallel, and they go up to that gray connector. So you have bus plus on one terminal up there from the bridge rectifier and bus capacitors, and then you have the it's either collector or drain of the MOSFETs or NPN transistors. One day I might get down there and take that apart and see if I can see the part number. But they're both right there. And when they're turned on, that regenerative braking resistor is connected to bus ground through those transistors right there. Now you'll see some resistors up here, and they take that high voltage and current limit for the LEDs. I've had this board removed so I could figure out how to power it up. I didn't know how to power it up. Now down here, over here is the top of the drive. This is pin 1 and pin 3 where you apply that 220 volts AC from the Variac to these two pins right here. Don't connect them to anything else. You'll be buying you a new board or a new bus power supply because this circuitry over here, this is all low voltage stuff right here. The pins 1 and 3 are routed through this board to this red and black wire right here that go over here. You can see there's a pre-charge relay and a pre-charge resistor right here, and that red and black wire from pins 1 and 3 go to this bridge rectifier to power up the switch mode power supply. Over here is the switch mode power supply IC right here. Down here are the MOSFETs and diodes at the output of these switching transformers right here. Or I'm sorry, at the input, the switching MOSFET right here would drive into the primary side of that switching transformer. This transformer right here makes I don't know, it's about 50 volts AC, and that comes back up this red wire to this circuit right here, to the primary side of this transformer that powers up the control. Now, there's no, that I've been able to see, there's no microcontroller, there's no logic here on this board. It's all very small ICs, and this board's conformally coded. I don't know, I can't read the part numbers through that conformal coding, but it's all surface mount ICs of 8-pin values, so I don't see any outright logic. Maybe one of these little 8-pin ICs is a microcontroller, but I can't tell. I'll put a picture up of this board. Here they have a plastic insulator to insulate it from this metal plate, and it folds over the top so that if this was to explode, it would explode into this plastic and protect this circuit board right here. There it is. That's what's inside. You have the power section over here, and you have the control voltage switch mode power supply board right here. There we go. Now we're done. I get a little bit long-winded every now and then, but this stuff is really complicated. Well, I hope you learned how to bring up this contactor right here and route the DC voltage out to the bus power supply terminals. That way, when you get it on your bench, you won't be scratching your head trying to figure out why that contactor don't come in. You got to have that resistor out there on the regenerative brake and resistor connector. Okay, 25 ohms, 225 watts here in the shop. We'll see you. Have a good day. Evening all. Here's the green Phoenix connector on the front of that new bus power supply. I got this little indication here. The Phoenix connectors, they'll have a flat edge and then they'll have a curved connector on this side right here. So you don't plug it in backwards. It's kind of like a keyway on a military connector you see in the aircraft of the USAF. Pins 1 and 3. That is where I applied VAC in of about 220 volts AC, single phase, to pins 1 and 3, pin 2 being no connection, to power up the control. That brought up the switch mode power supply in that bus power supply. Pin 4 is no connection. Now let's go back up to 1 and 3. Pins 1 and 3 are probably, and I'm not sure, and I'm afraid to increase the voltage on pins 1 and 3. I hate destroying things because I'm stupid. Does that make sense? So when I brought the Variac up, so at about 150 volts AC on pins 1 and 3, the green LED for the control voltage turned on, and I snuck up on it with the Variac. And at 220 volts AC, I stopped. And I stopped because I did not want to destroy that circuit for me increasing the voltage up to 380, 460 volts AC single phase on 1 and 3. I got scared. I said, okay, we're powered up. I'm stopping right there. Now, in all actuality, you could probably apply 380 volts AC, single phase on 1 and 3, because the front panel said that this drive would, the AC voltage into this drive, L1, L2, and L3, was 400/460. But doggone, I got enough to do, and I didn't want to chance tearing up this drive by applying too much voltage to that Phoenix connector on terminals 1 and 3. Whatever is my logic for that. If y'all had ever tore up something from being silly, tore up something from being stupid, you try not to do it again. Let's get sidetracked here. I had a board come into the shop. It was an operator panel. And the note said that on this operator panel, you apply 24 volts DC to these two terminals. And so I applied, because the customer said that's that voltage. You put 24 volts DC on these two terminals. I applied 24 volts DC to the two terminals that the customer said that's where it goes, and I fried that operator panel. Every frickin' IC was smashed because it was not 24 volts DC. It was 5 volts DC. I was crushed for about a month after that. And ever since then, I absolutely do not believe what the customer tells me is supposed to be there when it's not supposed to be there. I go and I inspect for myself to make sure that what the voltage input, I go check for myself. I quit trusting the customer to tell me what's supposed to be there. Anyways, enough of that. If we go down to 5 and 6, we have relay common contact on terminal 5. On 6, we have a relay normally open contact. And I'm thinking that's an alarm relay. So that if something's not quite right, these two contacts right here will close. Pin 7 again, no connection. Now here is a little bit strange. We have a power supply of plus 10 volts and ground. I called it ground 1 because we have ground 2 down here. So we have plus 10 volts on pin 8 and minus 10 volts on pin 10, reference to pin 9, this ground. Now whenever I see plus and minus 10 volts in ground, I think this is a speed reference for a potentiometer. But now why would you put that on the bus power supply? Why not on the drive? Really odd. Now on terminal 11, reference to 12 and 13, ground 2 and ground 2 here, we have a plus 25.27 volts DC, and I'm thinking that's probably a 24 volt power supply. It floats up to 25.27 unloaded. Now on terminal 14, that's a reset input. Now I never tagged that input up, so I don't know what we're resetting. Maybe a fault indication or something like that. Down here on 15, we have ground 1 again. That's tied to terminal 9. And terminal 16, we had 15.07 volts DC. Now I followed terminal 16 back in, and it went to a heat sink thermal on one side. So here on 16, the wires went to a heat sink thermal internal to the bus power supply, and I don't know where the other side of the heat sink thermal went to, but when I measured 16 to 15, I had 15.07 volts DC. Now this is an output. I'm not sure where it goes to. If I had the whole machine here, I could tell you where that goes to. But it's probably seriesed with another thermal in the machine. And if that thermal switch in the machine, wherever that's at, opens up, or the heat sink inside the power supply opens up, we get a thermal alarm. And up here on the relay common contact and relay normally open contact, they would probably close because of the alarm. Well, you got to hear about my stupidity with not checking whether we had 24 volts or 5 volts on that operator panel. Probably be up all night thinking about that damn crap. It's been a hell of a week. I've been thinking about my son and putting up videos out of his hard drive we found in his place where he lived at. Oh, hellfire. Okay. The only thing I got to say about this is be careful up here because I'm really not sure. I didn't want to go above 220 volts AC single phase on pins 1 and 3. Don't get backwards. Don't take and put this high voltage down here. This is the top of the drive. This is the bottom of the drive. Don't put this down here because this low voltage stuff does not like that high voltage stuff.